Assalamualaikum and hi, my name is Muhammad Hilman bin Rosmi with metric number of DN180092. I will present about my project entitled Effects of Glutaraldehyde Crosslinker on Surface Treatment of Level 1 Sportswear Fabric using Tourmaline, Physical and Mechanical Characterization under supervisor of Dr. Nadirul Hasraf bin Maknayan. Sports have become favorable to people nowadays due to its benefits of producing healthier mind and body. However, performing the activities will cause the attire to drench with sweat, which will become medium for bacterial and microorganism growth. Hence, development of sports attire have been done to enhance the property of the sportswear. The development done include infusing other substances such as mineral particles into the fabric to introduce the fabric textile with additional property of the mineral. One of the minerals that have beneficial health properties is tourmaline. Tourmaline is one of the anion minerals that have been studied for a very long time. However, the optimum performance of the mineral are still being measured. This study was conducted to observe the effect on physical and mechanical properties from the surface treatment on level 1 sportswear with tourmaline using glutaraldehyde crosslinker. Surface treatment was utilized in this study due to its advantages to able to produce highly efficient, cost-effective, durable textile, and also because of the method was really sustainable. The objective of this study was first is to study the infusion process of tourmaline into the fabric using glutaraldehyde in the crosslinker. Second, to characterize the physical properties of level 1 sportswear with tourmaline. And lastly, to observe the mechanical properties of level 1 sportswear fabric with the tourmaline. Now, let's move to the literature review. Study about tourmaline mineral have been conducted for a very long time. This mineral was initially famous due to its pyroelectricity and piezoelectricity properties. The mineral have been widely used in various industries such as textile, air and water purification, and agriculture. Tourmaline has 4 beneficial properties. First, tourmaline was known for its pyroelectricity and piezoelectricity property. Piezoelectric effect is deformation of structure or formation of electricity when being subjected to pressure, while pyroelectricity effect happen when the surrounding temperature change. The electrical properties change with the structure of tourmaline. This property is also a trigger to the antibacterial properties of this mineral. Next, tourmaline produces highest far infrared emission on wavelength of 1200 to 700 per centimeter. Smaller particle sizes would produce higher far infrared emission. This property helps by altering the cell membrane and metabolism process of the microorganism. Radiation of far infrared from this mineral will be able to penetrate through the skin and provide energy by vibrating the molecules in the body, causing the molecules starting to collide to each other and producing heat on the surface. This property helps in improving the healing of skin wound, relieve pain, stiffness, and enhance the blood circulation and others. Tourmaline has been utilized in fabric manufacturing. However, there is still no study regarding the minerals on the sportswear. Previous studies showed that the tourmaline provided an additional function and mechanical properties to the fabric, such as increasing its tensile strength. Additional of tourmaline also increased the surface energy due to the presence of electrical field modifying the structure. Lastly, tourmaline have been proven on improving the antibacterial properties on the fabric. There is 2 methods done on infusing tourmaline into fabric. They are electrospinning and surface treatment. Surface treatment is a process which involves the fabric being infused in the additive solution containing crosslinker, then being washed and dried. This method alters the surface molecular structure to create a strong bond between the surface and the adhesive or the additive. Meanwhile, the crosslinker used in this study is glutaraldehyde. Glutaraldehyde is a homobifunctional reagent which have been widely used in the industry due to its availability and low cost in contrast to its high reactivity. It also has been used in various fields including biohistochemistry and cytochemistry. This study was started by conducting acid treatment process to the fabric using sulfuric acid for 2 minutes. Then the fabric was let to dry. Preparation of tourmaline dispersion was conducted by mixing the tourmaline, CROSSLINKER, and water at concentration of 3%, 1%, and 96% respectively. This study also being conducted by using 2% to 5% of glutaraldehyde CROSSLINKER with 3% of tourmaline. Then the fabric was dipped into the dispersion and dried. The sample will undergo physical and mechanical testing to characterize the product form. The fabric testing method conducted was first SEM, which was used to observe the surface morphological detail of the tourmaline fabric. In this testing, the sample was cooled at 10 nanometer thick before being put inside the testing equipment. 1000 times and 500 times magnification was used in this test. EDS was used to analyze the presence of tourmaline in the fabric. EDS was equipped at SEM with 183 electron volt resolution. Next, SRD was used to get molecular structure information to evaluate the degree of crystallinity and crystallite size of the sample. The sample will be monitored at 5 to 80 degree diffraction angle using monochromatized cuprum K alpha radiation at K 1.54051 degree A. And lastly, tensile strength test was conducted to evaluate the tensile strength, elongation, and modulus of the tourmaline fabric. Tensile testing was utilized by using 50 millimeter per minute of constant cross speed. Now, let's move to the results and discussion part. The figure showed the SEM image of untreated, acid-treated, and tourmaline-treated fabric. From the figure, it can be seen that the untreated fabric has a smooth surface due to the structure not yet being modified. As the fabric being treated with acid, small morphological structure change of the surface can be seen as the surface becomes rougher due to the opening of free space on treated surface. Acid treatment help increasing the cross-linking reaction of tourmaline to the fabric becoming easier. On the tourmaline treated fabric image, small bits formation can be seen on the treated surface indicate that the presence of tourmaline particle on the fabric surface. The tourmaline might have early reaction with glutaraldehyde during dispersion solution. Preparation caused by the tourmaline to clump on each other and attach on the fabric surface instead of properly dispersed into the fabric thread. The early reaction during dispersion preparation process resulting to small reaction rate to infuse the mineral onto the fabric, thus making unable to evenly spread the tourmaline particle on the fabric surface. EDS spectrum proven the presence of tourmaline on the fabric surface as is able to detect element associated with the tourmaline, that is silicon. EDS not able to detect the other component related to the tourmaline such as aluminium and lithium, may be due to the very small amount of them in the sample. Next, SRD pattern show the small change of peak formation between unsaturated fabric and tourmaline treated fabric. Untreated fabric has peak formation at about 15 degree, 20 degree and 35 degree diffraction angle. Tourmaline treated fabric have same peak with slightly increased intensity and also a new peak formation at about 27 degree diffraction angle, showed that there is a minor structure change due to the presence of tourmaline on the fabric. There are also enhancement of mechanical properties in tourmaline infused fabric. The stress versus strain graph showed that the tourmaline dispersed fabric produced significant change on tensile strength compared to the untreated and acid-treated fabric, where tourmaline infused fabric has higher tensile strength at 37.5 megapascal compared to acid-treated with 23.2 megapascal and untreated fabric with 23.15 megapascal. High tensile strength of tourmaline fabric was due to the load imposed to the fabric surface was being distributed to the tourmaline particle attached on the treated surface. As the force being distributed to the minerals particle, the fabric able to withstand the higher force compared to the untreated fabric. Moreover, fabric containing tourmaline has highest Young modulus compared to the untreated and acid-treated fabric. The Young modulus indicate that the fabric was stiff, resulting to the small elongation value. This is because it will take more force in order to stretch the stronger fabric compared to the lower tensile strength fabric. Elongation of unsaturated fabric was the highest due to the fabric only required small force to stretch the fabric until the part of the point where the fabric unable to return back to its original form. As for conclusion, tourmaline nanoparticle was successfully infused into the level 1 sportswear fabric using glutaraldehyde crosslinker. SEM image showed that the formation of bead formation on the thread surface of tourmaline infused fabric. Next, EDS and SRD spectra proven that the presence of tourmaline through the formation of silicon peak at EDS spectra and small structural change on SRD spectra. Lastly, the enhancement of mechanical properties of tourmaline fabric can be seen through the highest tensile strength and Young modulus of the fiber. Further study should be conducted to observe the effect of crosslinker to the negative ion properties of the tourmaline, in which more testing such as data potential analysis should be done in the future. The testing will be a great help to able to have a more understanding on the reaction of crosslinker to the tourmaline fabric. That's all from me. Thank you.